Hello, I'm going to introduce my project, Transmit Compressed Signal via FDMA, and my name is Chandai. We're going to start with the introduction, and the goal of this project is we're going to transfer video stream or image via FDMA, and we'll try and find a way to optimize it. And how this project set up. For this project, we can only transfer the digital data, so therefore we have to convert those original data into bits, and then we will build a FDMA system to transfer the signal. And to optimize it, we will use compression on both sides. Therefore, it will help us to create a better efficiency. And the compression method we're using today is MPEG, and in the MPEG it has two kinds of structure. The first is the structure of the MPEG, and the second is the method the MPEG is using. Both of this feature will compress the entire data very in a good way. In this slide, I'm going to introduce the MPEG compression, and it has two separate ways I just explained before. And for the MPEG compression structure, we have three different frames, which is called I frame, P frame, and B frame. And they are coded. All of those are coded in a microbox, and in the microbox have one iframe, many pframe, and a lot of bframes. And I'm going to introduce the detail of those. And you see the image. This is a pframe compression. All those pframe are coded by the previous keyframe, which can be the previous pframe or previous iframe. And iframe is the real keyframe and is coded independently. The method is similar with the JPEG. And for the next is going to be the bframe. Bframe are coded very specially. It can code in the previous keyframe or the later keyframe, which could be both I or P frame. And B frame will save the storage significantly. And the key idea impact on the structure is like this. So for the way it's compressed, the iframe is as follows. It's using the DCT algorithm, which the idea is no matter what the wave is, all of the wave can constructed by some kind of cosine wave, and it's using the same idea. As you can see the photo, this is a photo generated by the cosine. Just like the DCT algorithm, all of the image can created by some combination of this image with some parameter involved, and therefore we can construct a small block of the image, and we can divide the entire image to separate different of the block. Therefore we'll have our image compressed, and this is basically the idea how iframe compress. And the relation between JPEG and MPEG is they're both using the same idea. So therefore, for the later experiment, I will use the JPEG to do the experiment, which is much easier and much more clear. And this slide, I'm going to introduce my module. The traditional module, as you can see above, is we transfer the signal via FDMA and by space coding, and the original signal will come in and then do some process and then finally goes out. And my idea is to have a signal compressed before it go to FDMA, and then we'll have a compressor after we receive the signal. Therefore, we can optimize the the transfer time, which means we can use less time to send more data. For the FDMA module, we have 4 steps. The first is modulate the signal, and the signal is come from the compressed signal. And the second is modulate this signal, which will send the modulated signal to the channel. And the third is compress all those signals together and transfer it to the destination. The last step is demodulate the signal. Since all those signals are modulated for easier transform, we are doing the demodulated signal to recover the original data. Then we also have 2 different module outside of the FDMA, which the first is the compression, the second is decompression. For the compression is we put the image to the preparation, which will do sampling and quantization. Then we'll do the DCT algorithm to do the compression. And finally, we have the compressed data and we'll send it to FDMA and do the signal transfer. And when the signal reach the decompression part, it will do the exactly inverse version of the compression. And finally, the original signal will receive at the user side. And here is the similarity result about the MPEG. And the first are showed for the overview of the total frame. And in this sample we have 17,098 frames as total, and the average compression rate is 156, which is very good, very high, which means for a 10 megabytes file we can transform just using like transform 1 megabyte files time. And then the rest of it are the individual frame status. For the iframe, you can see compared to the total frame, it's only take a few amount, like 1/10, and the compression ratio is relatively small, it's 56, and the size is kind of steady since it's coded individually. For P frame and B frame, you can see P frame has a lot more compared to iframe, and the compression ratio is also higher, which is 130. And due to the feature of P frame can coded by the previous keyframe, so some minimum frame will have very low size, just like we copy directly from the previous frame. And this thing also happened to B frame, and you can see B frame has a lot more compression ratio, and this is the main focus. Why this MPEG have so high compression ratio overall. As a conclusion, we can say it's greatly saved the space, of course, and as a result, we can transform a smaller file, which means we can save the time and bandwidth for the identical same file. And for this slide, I'm going to introduce a JPEG conversion. And this is for the image transform. Also, we can have a detailed look about how iframe are look like. And you can see the TGA file are the original uncompressed file, and the JPEG file are of course the compressed file. The overall the ratio is 2.899 or 3.61. As you can see, there is a lot of difference because we're using the highest quality. So therefore, is getting a very large since we keep as more variable as possible. If we use a very low quality, it will be similar to the iframe, um, which satisfy our algorithm and satisfy how iframe look like in MPEG. And in this slide, I'm going to introduce the FDMA modulation simulation result. And to do the experiment, we have 8 different signal, which are 13, 14, 15, 15 16, 8, 18 to 100. Also, we have a carrier frequency at 300, 600, 900, and 1200 and extra. And to do the convenience, I only pick 3 signals to do the presentation. And these 3 are 30 Hz and 50 Hz and 80 Hz. And the top level is the original signal, and the second is modulate signal, which are easier for transfer. And the third last is the decompressed modulated signal. As you can see, our FDMA do recover the signal properly without any error, which means the signal are this modulation are pretty good. And for a combined aspect, and this is what actually these 8 different signals look like inside of the channel. It is very hard to identify by humans, and machine can find out by using the bandpass filter. And the conclusion is still satisfy the algorithm, which we try to solve, and it still finish satisfy our purpose. For the future work is we still have something to improve in this project, and first is signal input. Um, Currently we are using the generated signal to do the transform, and if we can, we can use a compressed signal to do the simulation, and this will make the experiment much better. Also, for the signal channel, we now make assume the environment is perfect and we don't have any lossless or any echoes between the channel. So we can have we can put it into the real world and to see what's happened. And the third is for now we don't have the latency and bandwidth testing, which is kind of essential for this project. So if the latency is very low, and therefore we can use this, is if the latency is very high, therefore we'd rather use the traditional version. And the last is we can support various file, and currently just image and video stream are supported. If we can have other kind of file supported, and this will be a much better extension.